Hello, good morning friends. So in this lecture we will continue our previous topic, that is block diagram algebra, and we will study these topics, that is shifting of a summing box across a block, interchange of summing box, control system with feedback, control systems with multiple inputs and multiple output systems. Okay, so let's start the first topic, that is shifting of a summing box across a block. Here there are two cases, whether we want to shift a summing box from a position before a block to the after a block, or from after a block to the before a block. In this case 1 is considered as, that is, if we want to shift a block, this block, from before a block to the after a block. Okay. Now in this case, because here we have put plus minus sign, at this instant we will get rs plus minus x1s. So this will get multiplied with gs, and we will get gs rs plus minus gs into x1s. And we want to shift this summing box, so we need to add an additional box here that should also have the same condition that we get in the previous case, that is this one. Okay, the output should not change. No, now in this way we have to add an additional block with the transfer function gs in path of x1. Okay, so that the output will remain same. Now in second case, we want to shift this summing box from after a block to the position from new before a block. Okay, now if we solve this, we get that cs is equals to rs, because this rs will get multiplied with this cs only. Okay, and in this way we will get the output rs multiplied gs plus minus x1s. So when we shift this summing box from this position to this position, then we will get this architecture. In this way we have to divide, because at the output we do not need gs multiplied with x1s, so we have to divide it by g1x. In this way we have to add an additional block with transfer function 1 by g1s. Now the second point is that we want to interchange these two summing boxes. Okay, now there are two inputs, that is x1 and x2 are combined with these two summing boxes, then output will be, that is, rs plus minus x1s plus minus x2s. And this is a, you can say that this is a commutative property, so you can easily shift these two boxes with this one, that is x2 is replaced with x1, because these two summing boxes are look alike, so you can simply interchange these two inputs, that is x2x and x1x, and we will get the same output as with the previous output. Okay, the condition is that there should not be any take-off point in between these two summing boxes, or there should not be any block between these two summing boxes. So in that case we cannot interchange these two summing boxes. Okay, now the next topic is, that is feedback control system. Now here are three possible cases are there, that is either negative feedback control system, positive feedback control system, depending on the sign of the feedback which we are using here. It is either whether it is minus or whether it is plus, because in that case the output will change. Okay, Now, in when the negative feedback is there, then we will get the output Gs divided by 1 plus Gs into Hs. That is, if negative is there, we use here plus sign, and in case of positive feedback is there, then we will get the output Gs divided by 1 minus Gs into Hs. That is, when positive feedback is there, then we will get a minus sign here. In the special case of these two, if we use feedback with unity gain, that is unity feedback control system, in which the transfer function of the feedback path is 1, then in that case this hs becomes 1. In both these cases, this hs becomes 1, and we will get the output as 1 plus gshs, or if there is a plus sign here, then we will get minus here. So correspondingly, minus plus will reflected as plus minus in this case. Okay. The fourth case is the control system with multiple inputs and multiple outputs. Suppose we are using a system like this, which contains two blocks and a one output with two inputs, that is, one is at this position, this is your rs, and another is at this position, this is your u1s, and this is g1s, and this is g2s. Okay, and we want to find out this output. So in this case, we have to use superposition theorem. Okay, now in case of superposition, we use only one input as at a time and suppress the another input at the that instant. So when u1s is equals to 0, then output c1s will be there. When rs is equals to 0, then c2s will be the output. Okay, these two are the outputs. So when we use this method, then simply you can say that it looks like this, that is c1s, when in first case when this will be 0, then we can see that, and there is no meaning of this summing box. Okay, we can remove this summing box, and we will get this output, that is g1s multiply g2s in series. So we will get the output rc1s, that is equals to rs g1s into g2s. But when this case is there, then because rs is equals to 0, so 0 multiplied g1s will give us 0, and here if one input of a summing box is 0, then it is meaningless to have this summing box, so we can remove it. Then in that second case, we will get only this g2s as the input, and this is, that is u1s, and we will get only c2s is equals to u1s g1 g2s. So the net output will be the sum of these two outputs, that is c1 plus c2, and that is cs is equals to c1 S plus C2S. This is RS G1S G2S plus U1S G2. Thanks for watching this video, and we will continue the example of multiple input multiple output control system in our next lecture. Thanks for watching this video again.